In trig, a reference triangle is something that is drawn on a coordinate plane. In other words, it's drawn with 0, 0. Okay, drawn on the coordinate plane. So that means with 0, 0. So if you're ever asked, okay, construct or draw a reference triangle, you know that you've got to draw a coordinate plane. I'm not going to require you to draw it on graph paper, but there is still the graph paper in the modules if you want to use that, or if you want to turn your Notability into graph paper, but I'm not going to require that for right now. At least, though, you'll need to sketch a grid. So let's just review a couple things about this grid and which quadrant is which. So we've got quadrant 1, which is the primary quadrant, and y'all know about that, and then it works its way counterclockwise to quadrant 2. And then we have quadrant 3 down here in the diagonal across from quadrant 1, and then quadrant 4 is the last quadrant beneath quadrant 1. So that's the coordinate plane we're working with. When you construct a reference triangle, there are some requirements. So let's make sure we all agree on those. So reference triangle requirements. And there are 3. Now, if I told you draw a triangle on the grid, there are lots of different triangles that could be constructed. The most common triangle that I see is a triangle that looks like this. Okay, putting a right triangle on there. Okay. The problem with that right triangle is it violates the first rule of the requirement of a reference triangle. Right here, where is the right triangle, or the right angle right now? It's at 0, 0, right? It can't be at 0, 0. Okay, that's one of the rules of a reference triangles. You can't put the right triangle, the right angle on 0, 0. Okay, what does go through 0, 0 is the hypotenuse. All right, so the hypotenuse must go through 0, 0, or it goes through the origin. So that means all of your triangles that you could draw need to be extending out from the origin that way. The hypotenuse has to go that way. And so your right triangles you could possibly construct would look like that. In every quadrant, the hypotenuse has to connect to the origin. So that leads to the second requirement. Well, what do you do with the right angle? And so the right angle has to be on the x-axis. So that must touch the x-axis. So what that would do is it would make sure that nobody drew a triangle like this. Okay, well, it's possible to draw a triangle like that. The problem is that the right angle is touching the y-axis, and that is against the requirements of a reference triangle. And so we don't want it there. We want our reference triangles to be touching the x-axis. And so in every situation that you would create a right triangle, so it sort of should end up looking like a bow tie, right? The origin is right in the middle. It should be a nice bow tie looking thing. Those are 4 reference triangles. Okay, and the third requirement is the placement of the theta value. Now, we talked about theta being one of those Greek letters yesterday, and theta has a specific position. So theta is the thing that must be at the origin. And so when you construct, you'll have a theta here at the origin in quadrant 1, or a theta at each of the other corners. It's always the corner that's nearest to the origin. That's the position of your theta. So whenever you're asked to draw one, make sure that what you're drawing, you only draw one at a time, you won't draw multiple, but make sure it's part of what could be a bow tie. Okay, so picture it that way. Okay, now we want to label some pieces of our reference triangles here. The hypotenuse, those yellow lines that I've drawn, those are always going to be positive. It doesn't matter what quadrant that they're in. The hypotenuse is always a positive number. I don't care if it's in quadrant 3 or 2 or anything else, it's always a positive value. Okay, now the other sides of the different triangles. On the x-axis, if we're to the right, then of course that side would be positive, but if we're to the left, then that side would be negative. And that attaches itself to both the triangle above and below. So that base value b is going to be positive if it's in quadrant 1 or 4. It'll be negative if it's in quadrant 2 or 3. And then the last sides, the vertical sides of the triangles, of course, if you're in quadrant 1, it will be positive. But if you're in quadrant 4, that side would be negative because it's below the x-axis in quadrant 4. And then in quadrant 2, of course, if you're above the x-axis, then that side would be positive. But if you're below the x-axis, then that side would be negative. So where is the triangle with the most negative parts? Quadrant 3, right? How many negative parts does it have? 2. Because what's always positive? The hypotenuse is always positive. Okay? So the most negative parts would be in quadrant 3. It would have 2 negative sides, but the hypotenuse is always positive. Quadrant 2 and 4 both have a single negative side in a different position, and quadrant 1 would have them all be positive. All right, so you just have to understand some of the descriptions and requirements of a reference triangle, and now we're going to actually start working with drawing our own and seeing how that works out. So here's how you're going to work with reference triangles in trig. All right, so draw your own reference triangle through the point P being 12, comma, negative 5. Okay, 12, comma, negative 5. And then find the 6 trig values for theta. Okay, so those are the instructions. We're going to do a little setup here before we get going. We know we have to draw a reference triangle, so we're going to make ourselves a grid. Like I said, you don't have to use graph paper, just at least a grid, but you do need to draw it. And then we're going to find the 6 trig values, so I'm just going to get myself set up here. Sine theta, cos theta, tan theta. And then across from each of those, I will do their counterpart. So cotangent theta, secant theta, and cosecant theta. So I just like to kind of get set up, and then I'll attack the problem now that I'm all ready, sort of like a template. Now the first thing I want to do is get the point drawn on there in the right quadrant. So what quadrant is 12, negative 5 in? Quadrant 4. Okay, so let's put 12, negative 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1, 2, 3, 4, 5. So I'm going to have my point P be right there. And from that point P, I'm supposed to construct a reference triangle. And so I'm going to make sure my hypotenuse goes back to the origin. I am going to make sure that I have a positive side length of 12 And then because I'm in quadrant 4, I will have a negative side length of -5. So I knew I counted over 12 and I counted down 5. My right triangle needs to go in the corner that is touching the x-axis. And my theta needs to go in the corner up here by the origin. So now I've drawn the reference triangle. What's the only piece that's missing? The hypotenuse. Okay, how can I find that hypotenuse? Sure, and it's always going to be a positive number. So I'm going to work on the side here a little bit, and I'm going to work out my Pythagorean theorem. So that would be 12 squared plus -5 squared equals the hypotenuse squared. Now I'm going to really encourage you to use parentheses, especially around a negative number, because the danger of what happens, let me just show you what your calculator will do. When you don't use your brain and you trust your calculator, and you go to your calculator and you type this in, -5 squared, and you're not using your head, and you see -25 and you just put -25 and you go on your merry way, you're going to get a totally wrong, you're going to hypotenuse that's too short. Hypotenuse is going to be smaller than the other sides, which is impossible. It's not possible for that to be true. So be smart about it. -5 squared should be a positive number. And the only way it'll be positive is if you put parentheses around -5 and then square it. So use your head. Don't just always go back to your calculator. So we've got 144 plus +25 equals c squared. That's 169 altogether, which, according to the math fact, works out perfectly to 13. So my hypotenuse is 13. Remember, it should be a positive number, and it should be longer than the other sides. If it's shorter, you did something wrong. Once you have your reference triangle all drawn and labeled, then you can fill in the first 3 of the trig values using SOHCAHTOA. So we just need to go from theta, we need to find the opposite side. Okay, so Devin, you were thinking about that. So for theta, if you want to practice your SOHCAHTOA, what is opposite? Okay. Okay. Yep. Okay. All right, yep, hang on, whoops, let me catch up to you a second. Okay, so his first 3 are all fine. Okay, he did his SOHCAHTOA completely right. -5/13, +12/13, -5/12. Okay, now, when you move over to the other 3, okay, tell me what you had for cosecant. Okay, the negative stays in the numerator. All right, it doesn't go down to the denominator, or if you just wanted to sort of put it out front and not really have it be part of the numerator or denominator, but the negative doesn't, it's either in front or in the top. It never would travel down to the denominator. So that's just kind of a form of math, formatting for math. Okay, and so then what would you do with cotangent then at the bottom? Yeah. Okay, great. Any questions on that? He did a super job finding his 6 SOHCAHTOA values, the 3 SOHCAHTOA values, and then the other 3. Okay, let's practice another one of those in a different quadrant. So same type of problem, different quadrant. So draw a reference triangle. And this time we're going to go through the point -rad5, -rad2. And then we're still going to find the 6 values for theta. All right, so while you're copying that, I'm going to go ahead. I really like to just have my template ready to go. So I'll put my coordinate graph on there, and then I'll get my 6 trig values in place, ready to go. It also helps me, by following that pattern I showed you yesterday, it helps me to remember which one goes with which. Okay, so while you're working on that, can you tell me what quadrant this particular point will be in? Yeah, quadrant 3. We know it's quadrant 3 because both the values are negative. Now, I know it's radicals, so we're going to have to estimate where this is. The square root of 5 is not a math fact, and so we want the square root of 5 is going to be a 2-point-ish. And so when we graph this, we want to go -1, -2, and a little bit more. And then rad 2 is not a math fact either, so that's going to be about 1.4. And so if you're estimating your point, it'll be about right there in quadrant 3. Again, it does not have to be perfect, but you should have a sketch and then draw your hypotenuse back to the origin and then create your right triangle. Okay, remember the right angle goes on the x-axis. We counted back negative rad 5, so that's how long that side is on the x-axis. We counted down negative rad 2. And theta has got to be the corner closest to the origin. So now I'm going to use Pythagorean theorem to find my positive hypotenuse. Again, here's another place, if you don't use parentheses, you're going to end up with a hypotenuse that's either negative or smaller than the other two sides, both of which would be sort of disastrous. So make sure that you do parentheses negative rad 2 squared plus parentheses negative rad 5 squared equals c squared. Year after year I see mistakes with those parentheses, so just be careful about that. When we square something, it comes out to be positive 2. When we square negative rad root 5, we get positive 5. So that's 7. So the square root of 7 is my hypotenuse, which is positive and it's longer than the other two sides, so I feel good about that. So we've got negative rad 5 on one side, negative rad 2 on the other, and positive rad 7 as the hypotenuse. Okay, Mary Lou, you want to do sine, cosine, tangent for us? Good. Opposite is negative rad 2, and then over rad 7. Now one thing I want to comment, the rads don't cancel out. It's not like this is going to just be 2/7. Okay, radicals don't reduce. Okay, next one. Okay, negative rad 5 over rad 7. Again, radicals don't reduce. Okay, now the radicals don't reduce here, but what does? Or anybody? Okay, the negatives do. Okay, the radicals don't reduce, but negatives certainly do. And so this would be a positive rad 2 over 5. All right, so then once, because Mary Lou so successfully got us our first 3 trig values, now we can flip them. Just remember that the negative doesn't travel to the denominator, so negative rad 7 over rad 2, negative rad 7 over rad 5, and then positive rad 5 over rad 2. All right, any questions about that type of problem? Okay, now we're going to work backwards. Okay, so now you just got to stretch your brain a little bit and try and think, okay, now I've got to think about how do I create something like that in a backwards way. And that's always a test of whether or not you really understand what you're doing. All right, third example. Construct a reference triangle for sine theta equals 3 over 7. And for tan theta being less than 0. All right, construct a reference triangle for that. You don't have a point, you don't know the quadrant, so there's lots of possibilities for this. So let's kind of think about this, the different possibilities we could have. It could be in quadrant 1. It could be in quadrant 2. It could be in quadrant 3, or it could be in quadrant 4. These are my possibilities. Okay, a couple other things we know. Here's how we're going to think about working backwards. Sine is the fraction opposite over hypotenuse. So what can you tell me just by looking at the number 3 and 7? Hang on. I'm going to argue against that you don't know that for sure, but there is something you do know for sure. Okay, if we know that sine is 3 over 7, what do the numbers 3 and the 7 mean?
So 3 is the opposite, and the 7 is hypotenuse.
Okay, so 3 is opposite, and it's a positive number, and 7 is the hypotenuse, and it's a positive number. Okay, so we know that this is opposite. We know that this is hypotenuse. All right, so going back to our picture, we know that all the hypotenuses are going to be 7. We know that all the opposite sides have to be positive 3. So that could be here, but it could also be here, because both quadrant 1 and 2 have positive 3. So those are the possibilities. I have eliminated quadrant 4, because it would have had a negative, so I can get rid of that. We've eliminated quadrant 3, because it would also have a negative, so I can get rid of that. Okay, so now I just have to narrow it down one more time. The last thing I'm told is the clue that the tangent has to be negative. Well, tangent is made of TOA, right? Tangent is TOA. That means it's opposite over adjacent. We already know that the opposite is 3. The adjacent, we don't know yet. We could figure it out, but we know that it has to be negative overall. And so what do you know about the adjacent side? Not necessarily the number, but what do you know about its sign? If tangent is going to be negative, and you already know that the opposite is 3, what do you know about the denominator? It has to be a negative number. Okay, the adjacent must be negative. That's the only way. And so that eliminates the drawing in quadrant 1. It can't possibly be this one, because in quadrant 1, everything is positive. And we need for at least one thing to be negative. And the only place where one thing is negative is in quadrant 2. And so it has to be in that position. Okay, so now we can find it out with a squared plus b squared equals c squared. So we've got 3 squared plus b squared equals 7 squared. So that's 9 plus b squared equals 49. So b squared is 40. So b has to be the plus or minus square root of 40. Now 40 has a math fact in it. It's plus or minus 2 rad 10. And we know we need it to be negative. And so my reference triangle is going to be negative 2 rad 10. The positive one would have been on the other side. But I need at least one thing to be negative, because it told me that tangent has to be negative. So one thing has to be negative. It's the only thing. And then you could do the other 6 values if you were asked to do them, now that you've got your reference triangle drawn. I'm not going to do the 6 values with you. I know you can do that. I just wanted to practice working backwards with you and making a decision about the negative. So I want to try that one more time with you, as these are a little harder. Yeah? Can you see the whole thing? There. That's all I had. Okay, last one then. Our final example. Okay, so construct a reference triangle again. And we're going to do it for secant theta. Needs to work out to be 3. And sine theta needs to be positive. Okay, secant theta needs to work out to be 3. and sine theta needs to work out to be positive. Okay, so it could be in quadrant 1 or 2 or 3 or 4. So we just have to eliminate what it can't be. All right. This secant theta equals 3 gives me clues, kind of like sine theta of 3/7 gave me last time. Remember that 3 is over 1. Secant is the reciprocal of cosine. We know that cosine is adjacent over hypotenuse. So if cosine is adjacent over hypotenuse, what is secant? What's the order? Hypotenuse over adjacent. So hypotenuse has to be 3, and the adjacent has to be 1. The hypotenuse always has to be the longer one anyway. So now we know that all the hypotenuses have to be 3. We also know that the adjacent has to be 1. That's a positive number. The adjacent has to be this side right there. That's 1. It can't be on the other side because that would be negative. And so we can eliminate everything in quadrant 2. And we can eliminate everything in quadrant 3. So now I'm down to, I just have to make my final choice of which reference triangle is correct. And I lose my last clue, which is that sine is positive. And because it's positive, then I can't be in quadrant 4 either, because quadrant 4 has parts that are negative. So I eliminate quadrant 4. So that gets me down to, there's my reference triangle. And then I can use Pythagorean theorem to find the missing side. So it's going to be a squared plus 1 squared equals 3 squared. So that's a squared plus 1 equals 9. So a squared is 8. So a is the square root of 8, which has a math fact in it of 2 rad 2. And so that's the final missing side. It has to be positive because I needed everything to stay positive. And then you can answer the last 6 trig values of whatever you're asked for. Yeah. Okay. All right, so it's working backwards and kind of following the breadcrumbs. Okay, it's looking at what you're given and working backwards to eliminate the possibilities that can't be true. All right, any other questions about that? Okay, we're block day Thursday, which is a tutoring day. So if you get stuck in the next couple days, then Thursday morning, come on in and see me, or during break if you need a little bit of extra help getting this trig stuff under your belt as we start out. And then we're going to have an open quiz on block day 2 on SOHCAHTOA.